So I'm sharing my screen. Hopefully you guys can see it. But as the title suggests, what we do is ACH risk. So we don't process ACH, but we partner with our clients, our ACH processors, large originators, third-party senders, third-party sender providers that are leveraging the ACH network in some way. And we focus on real-time risk detection. Real time is important because if you've used ACH, probably the biggest pain point there is the fact that it takes 4 to 5 days to settle. So our big aim here is that we can be a clear enabler of faster digital payment experiences where payment companies can use our product to sort of bypass waiting for banks to confirm if the payment is going to clear or not. And the other element of our offering is that we are an API company, so we embed ourselves into the payment process of any of our clients, and that we're focusing very specifically on business use cases. So looking at things like, and maybe let me just share my screen so I can stop. 1 second. Yeah, so we focus specifically on business use cases, and I'll show you one of those right now, specifically as it relates to income markets and how small businesses are using our API to speed up and better protect the payroll process, which is one of the key, sort of the first payment use cases that you as a business, as a business owner, you would have to worry about. So I'll first show the experience of the payer, and then I'll show the experience of the developer that's actually integrating our product. So from and I mean, this might be familiar to you, but so our client in this situation would be the payroll, or our partner in this situation would be the payroll processing provider. So in this particular situation, let's imagine a CEO or an HR administrator of a small business that's using something like an ADP or a Gusto to process payments. They use that company to manage all, payment processing relationships with banks, but also a lot of the compliance elements of managing the payroll process. There's a couple of interesting things that happen today at the origination stage. One is that this business has a very comprehensive and live registry of all the payees in their network. So they're constantly collecting data, not just about the names, addresses, bank account information, routing information of their employees, but they're also catching things like what type of employee contract do they have, what type of behavior do they have with our website, when with our self-service website around them, including employee information and payment information. All of that is grabbed in the payroll processor's website. And obviously all of that is usually up to date by the time you introduce payroll. One interesting thing that not a lot of people know is that the payroll use case actually has baked into it 2 big payment types. One is closely, the closest call is bill pay, which is B2B debits. There's a relationship between the payroll processor that is collecting the funding that is needed to then execute B2C payouts, B2C pushes. So us as Nivelo, we look at both ends of that transaction in a single per transaction basis, not a batch basis. So both debits and credits, B2B and B2C. So when an employer is looking to execute payroll, at the point of origination of the payment, they're trying to figure out, and here's where the pain point comes in. They're trying to figure out, is this, am I properly funded for that payment? Will there be enough balance in the account? Is this the most accurate, the latest and greatest bank account information from our employees? is there any fraud associated with what's happening here? Things like synthetic identity, account takeover, even business email compromise, anything that could divert the flow of money from where you intended to go to somewhere else. That level of error, cyber threat error, has picked up in the income markets in the past 5 years, which is one of the reasons why we wanted to focus on it today. We hear a lot of headlines as it relates to benefit payouts from the government, but it's something that's happening as well in the payroll space. And usually when the most traditional solution that payroll processors are using to validate accounts and to validate transactions is to validate accounts by using micro deposits or any number of account aggregators. And that usually happens at account onboarding. What we're offering here is an API that works real time, that it's able to, within a sub-second speed, read each of those transactions and identify if there is any expected loss from the payment holistically, not just because the account may not be right, but if the employee's identity may not be right, if the flow itself may not be right, any element of the transaction, we look at it, and we use ML, and I'll talk about it in the developer view. In this particular situation, we're prompting the user with an alert that this particular transaction will probably lead to losses or delay due to what we believe to be impersonation fraud. So we prompt them to a phone verification where they would call the client and just confirm that the routing number and account, is right. And that's it. Honestly, like from the payer's perspective, our API is embedded into this UI. It allowed them to perform at all these risk verification services real time when they're originating the payment, as opposed to the alternative, which is waiting 4 to 5 days, hearing back from the ACH network, i.e. there's the sponsor bank, saying, hey, this transaction was a failure, here's the bank return code, or someone calling in saying, hey, I didn't receive my payment. Now on the, let me just quickly go back to our, sorry. So the other user here is our, the developer that is, or either the developer or the service staff within the payroll processor that's trying to investigate how did Nivelo handle that transaction, and what actually was going behind the scenes that prompted this particular transaction to be returned. On our particular developer dashboard, what we allow the users to do is to go within those transactions, get a little deeper in terms of what the score of that transaction was versus others, and get a sense of what prompted that return. So we're able to sort of, and the way that we identify risky situations and the way that we're able to do it in real time is by using machine learning, where we collect transaction details from our clients, not mainly the banks, but our clients, and are able to create an algorithm that helps identify what is atypical, what usually correlates with suspicious activity, fraudulent activity, or even credit risk activity. And so we're able to provide a view that allows the user to be able to say, look, this particular transaction was stopped because of these high-level trends in the transaction that that made us believe that it was fraudulent. Yeah, I mean, and from obviously from an API perspective, and I don't know if you can see this. Sorry, I'm trying to not bother you with all the notifications that I keep getting, which is why I came here. But from an API perspective, I'm highlighting here our our API endpoint just to show you a little bit of what our, for this particular client, their ACH input would be for us. The interesting thing here is that because we're tapping ourselves at the origination of the ACH transaction and not when it's batched and sent to the banks, we're able to work with more data. We're not just looking at the usual payload instructions, which you really only, you only hear about the routing number, account number, name, and amount. We start to give a little more flexibility and add additional details like what is the relationship between the payer and the payee? What is their interaction with the portal that allows origination? What was the last time that they changed their account? All of these things, which are not usually present in an ACH batch file, but because we're tapping in at origination, we get it. And we're able to send that through and obviously get an immediate pingback result. But we've created this dashboard because what we've realized during our first implementations is that, especially, we're talking about machine learning. So the beauty is in how you handle both the accuracy of the model and the precision in identifying bad behavior, but also handling false positives. It's never going to be 100% accurate. So we definitely have been experimenting with how do we explain what's behind the model to enable our users to create the best sort of UX experiences for their client. And so we are erring on the side of more transparency, more explainability in the model, as opposed to creating a black box situation where only the score is provided.